Here are a few important questions from the chapter Application of Derivatives. So these questions come as 2 and 3 marks questions. So let's see one by one. So example number 1, find the rate of change of the area of a circle per second with respect to its radius r when r equal to 5 centimeter. So given r equal to 5 centimeter, we need to find the rate of change of area of circle. Rate of change of area of circle is dA by dr. Find dA by dr when r equal to 5 centimeter. For this, we need to know the area of the circle. What is the area of the circle? Area of the circle formula is A equal to pi r square. So when we differentiate this, we get dA by dr. So on differentiation, we get dA by dr equal to d by dr of pi r square. So dA by dr equal to pi is a constant and differentiation of r square is 2r. So we can write this as dA by dr equal to, substitute the value of r. R is 5 centimeter. So pi into 2 into pi. So dA by dr equal to 10 pi centimeter square, change of rate of area of a circle per second. So centimeter square per second. This is the answer. We'll go to the next question. Example 2. The volume of a cube is increasing at a rate of 9 cubic centimeters per second. How fast is the surface area increasing when the length of an edge is 10 centimeter? So what is given? The rate at which the volume of a cube is increasing, that is dV by dt equal to 9 cubic centimeters. How fast is the surface area increasing? That is dA by dt. The rate of change of surface area when the length of the cube is 10 centimeters. So we need to find dA by dt. To solve this, we need to know the formula for volume of the cube and surface area of the cube. So formula to find the volume of the cube is V equal to x cube. Differentiate this. On differentiating this, we get dV by dt equal to, differentiation of x cube is 3x square into, since we are differentiating this with respect to time, we can write this as dx by dt. We know dV by dt, that is 9. So 9 equal to 3x square into dx by dt, or dx by dt equal to 9 by 3x square, which is equal to 3 by x square. So dx by dt equal to 3 by x square. What we need to find is area. We need to find the rate at which the surface area is increasing when the length of an edge is 10 centimeters. So to find the surface area, we need to know the formula of the surface area of cube. Area of cube is given by area is equal to 6x square. Now we'll differentiate. This is area. Area of cube. A equal to 6x square. So dA by dt equal to, differentiate 6x square, that is d by dt of 6x square. So dA by dt equal to, 6 is a constant, differentiation of x square is 2x into dx by dt. Or dA by dt equal to 6 into 2 is 12. 12 into x is given as 10 centimeter into dx by dt is 3x square, that is 10 square. So dA by dt equal to this will get cancelled. 12 into 3 is 36. 36 by 10 or 3.6 centimeter square per second. So dA by dt equal to 3.6 centimeter square per second. This is the answer. Example number 3. A stone is dropped into a quiet lake and waves move in circles at a speed of 4 centimeter per second. At the instant when the radius of the circular wave is 10 centimeter, how fast is the enclosing area increasing? So when a stone is dropped into a lake, the waves are moving in a circles. So the radius is increasing at the rate of 4 centimeter per second. So dr by dt equal to 4 centimeter per second. We need to find the rate at which area is increasing when the radius is 10 centimeter. So given dr by dt is 4 centimeter per second. We know the formula of area of circle, that is A equal to pi r square. So on differentiating this area, that is dA by dt equal to d by dt of pi r square. So we get pi is a constant and differentiation of r square is 2r into dr by dt. Now we know the value of r, that is 10 centimeter, and dr by dt is 4 centimeter. Substituting, we get dA by dt equal to 2 pi into r is 10 centimeter into dr by dt is 4 centimeter. So dA by dt equal to 10 into 2 20, 20 into 4 is 80. 80 pi centimeter square per second. The area is increasing at the rate of 80 pi centimeter square per second. Exercise 6.1, first question. Find the rate of change of the area of a circle with respect to its radius r when, there are two questions here, when r equal to 3 centimeter and when r equal to 4 centimeter. So given the radius of the circle is 3 centimeter, we need to find the rate of change of area of circle with respect to radius, that is dA by dr. What is given? Radius of circle r equal to 3 centimeter. We know that area of circle, formula for area of circle A equal to pi r square. So rate of change of area with respect to its radius, that is dA by dr. We need to find dA by dr. So on differentiating the formula, that is A equal to pi r square, we'll get value of dA by dr. So on differentiating this A equal to pi r square, we get dA by dr equal to pi is a constant and differentiation of r square is 2r. So dA by dr equal to 2 pi r. Substituting the value of r, that is r equal to 3 centimeter, we get dA by dr equal to 2 pi into 3 or dA by dr equal to 3 into 2, 6. That is 6 pi centimeter square per second. So when r equal to 4 centimeters, we get dA by dr equal to 2 into pi into 4. That is dA by dr equal to 8 pi centimeter square per second. Question number 2. The volume of a cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when the length of an edge is 12 centimeter? So what is given? Volume of the cube is increasing at the rate of 8 centimeter cube per second. That is dV by dt. dV by dt equal to 8 centimeter cube per second. How fast is the surface area increasing? That is dA by dt. How much is dA by dt when the length of the edge is 12 centimeter? So we need to find dA by dt. So to solve this, we need to know the formula of volume of cube and surface area of cube. So volume of cube formula is V equal to x cube. When we differentiate this, we get dV by dt equal to differentiation of x cube is 3x square. Since we are differentiating with respect to t, we write it as dx by dt. We know dV by dt, it is given, that is 8 equal to 3x square into dx by dt. From this we can find the value of dx by dt. Now the other formula, that is area of cube. Area of cube is A equal to 6x square. So when we differentiate this, we get the value of dA by dt. Area of cube is A equal to 6x square. When we differentiate this, that is dA by dt equal to differentiation of 6x square. That is 6 is a constant and differentiation of x square is 2x. So dA by dt is equal to 12x into dx by dt. Now we know the value of x, that is 12 centimeter, and we just got the value of dx by dt. Substituting the value of x and dx by dt, we get the answer as dA by dt equal to 8 by 3 centimeter square per second. This is the answer. Question number 3. The radius of a circle is increasing uniformly at the rate of 3 centimeter per second. That is dr by dt equal to 3 centimeter per second. Find the rate at which the area of the circle is increasing when the radius is 10 centimeter. Find dA by dt when radius is 10 centimeter. For this, we need to know the area of the circle. We know the area of the circle equal to A equal to pi r square. On differentiation, we get dA by dt equal to pi is a constant. Differentiation of r square is 2r into dr by dt. So we get the value of dA by dt as 60 pi centimeter square per second. Question number 4. An edge of a variable cube is increasing at the rate of 3 centimeter per second. How fast is the volume of the cube increasing when the edge is 10 centimeter long? So the edge of the variable cube, consider the edge of the cube as x. So this is increasing, the edge of the cube is increasing at a rate of 3 centimeter per second. That is dx by dt is given as 3 centimeter per second. Now we need to find the rate of increase in volume when x is 10 centimeter. Here we need to find the rate of increase of the volume of the cube when x equal to 10 centimeter. For this, we need to know the formula of volume of the cube. We know that volume of the cube is V equal to x cube. Upon differentiation, we get dV by dt equal to differentiation of x cube is 3x square into dx by dt. Now substituting the value of x and dx by dt, we get dV by dt equal to 900 centimeter cube per second. A stone is dropped into a quiet lake and waves move in circles at the speed of 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? So what is given? When a stone is dropped into a quiet lake, waves move in circle at the speed of 5 centimeter per second. That means the radius is increasing at the speed of 5 centimeter per second. So if we consider the radius as r, then dr by dt equal to 5 centimeter per second. Now we need to find the area, the rate at which the area is increasing when r equal to 8 centimeter. For this we need to know the area of the circle formula. So we know the formula for area of circle is pi r square. On differentiating and substituting the value of r and dr by dt, we get the answer. We get dA by dt. Next question. The radius of a circle is increasing at the rate of 0.7 centimeter per second. What is the rate of increase of its circumference? What is given? The radius of the circle is increasing at the rate of 0.7 centimeter per second. So dr by dt is given as 0.7 centimeter per second. We need to find the rate of increase of its circumference. If we consider circumference as c, then find dc by dt. What is the formula for circumference of a circle? That is c equal to 2 pi r. Now differentiating this, we get dc by dt equal to 2 pi into differentiation of r is 1 into dr by dt. So dc by dt equal to 2 pi into 0.7, or rate at which the circumference is increasing is 1.4 pi centimeter per second. This is the answer. Next question. The radius of an air bubble is increasing at the rate of 0.5 centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? What is given? Radius is increasing at the rate of 0.5 centimeter per second. So dr by dt is given 0.5 centimeter per second. Find the rate at which volume of the air bubble is increasing when the radius is 1 centimeter. So dv by dt is, find dv by dt when r equal to 1 centimeter. Since the air bubble is in the form of a sphere, we need to know the formula for volume of sphere. Volume of sphere V equal to 4 by 3 pi r cube. So when we differentiate this, we get 4 by 3 pi is a constant and differentiation of r cube is 3r square dr by dt. Substituting the values of r and dr by dt, we get dv by dt equal to 2 pi centimeter cube per second. This is the answer. Next question. The length x of a rectangle is decreasing at the rate of 3 centimeter per minute and the width y is increasing at the rate of 2 centimeter per minute. So if we consider length of rectangle as x and breadth of rectangle as y, what is given is the length of the rectangle is decreasing. That means we need to take this as a negative value. So dx by dt equal to minus 3 centimeter per minute. And the width is increasing. So dy by dt equal to 2 centimeter per minute. Find the rate of change of perimeter of the rectangle. We need to find the perimeter. So what is the formula to find the perimeter of a rectangle? Perimeter is equal to 2 into x plus y. So on differentiating this, we get dp by dt equal to 2 into differentiation of x is dx by dt and differentiation of y is dy by dt. We know dx by dt and dy by dt. Substitute the values of dx by dt and dy by dt here. We get the answer as perimeter. The rate of change of perimeter of the rectangle is minus 2 centimeter per minute. Now we need to find the area of the rectangle. What is the formula of area of rectangle? Area of rectangle A equal to x into y. So for this we need to use the UV rule. So on differentiation, we get dA by dt equal to, UV rule is d by dt of u into v equal to u into dv by dt plus v into du by dt. So on applying this here, x into dy by dt plus y into dx by dt. We know the value of x, we know the value of dy by dt, we know the value of y, we know the value of dx by dt. So just substitute and get the answer. So we have dA by dt equal to 2 centimeter square per minute. This is the answer. These questions usually come as 2 marks and 3 marks questions for your final examination. If you find this video helpful, please don't forget to subscribe.